Good day, good evening, and welcome to today's webinar. My name is Mark Cox, and I'm a Senior Communicator at INNIO. I'll be your host today. I'd like to welcome you to our webinar platform. You'll notice that this webinar is browser-based, so if you disconnect for any reason, please just click on the link that you received via email to rejoin the session. In order to ask questions, you can send them in via the Questions widget. Just type them into the box at the top left-hand corner of your screen and click Submit. We will allocate some time at the end of the session to address any questions or comments that you may have. Please use the yellow Help widget if you require any assistance, and you can move, resize, and maximize any of the windows in front of you to get a better view of the slides. But now, please allow me to share a short presentation about our company, followed by today's presenters. INNIO is a technology company developing, manufacturing, monitoring, and servicing gas engines for power generation and compression solutions. Our Jenbacher products are specialized in power generation. Jenbacher's North America sales and service hub is headquartered in Houston, Texas. We also have operations in Wisconsin, as well as in Ontario, Canada. INNIO's global headquarters and core innovation center is based in Austria. Out of the more than 3,000 global employees, over 500 highly qualified engineers are focused on innovation. INNIO's Jenbacher business has around 1,700 employees around the world. The first Jenbacher gas engine was manufactured in 1957. In total, Jenbacher's success builds on more than 90 years of engine experience. So far, about 22,000 engines for power generation and CHP have been delivered worldwide. Well over 1,000 of these engines went to customers in North America. Today, INNIO runs manufacturing facilities with a total of 65,000 square meters, producing 5 product lines of high-tech engines with outputs from 200 kilowatts to as high as 10 megawatts. Our engines are known for overall efficiencies of 90% and more. Their durability, fast start capabilities, and the ability to run on a broad range of fuels. Jenbacher also offers a comprehensive set of lifecycle services. Jenbacher has always been a front-runner in the gas engine industry. In addition to a series of world's firsts in technology, business also has a history of growth in the U.S. What started with a small sales and service office in Boston 30 years ago has grown into a strong network of INNIO and distributor sales and service expert teams across the USA and Canada. Jenbacher engines meet our North American customers' needs with top reliability and performance, delivering total efficiencies of up to 95% in cogeneration mode. We offer established, field-tested designs, optimized, robust engine components, along with a proven monitoring and control concept. Our engines can run on natural gas, as well as a broad variety of renewable or waste gases. This makes them a great solution for reducing our customers' CO2 footprint. With the capability to run on hydrogen, the potential to save even more emissions in the future is becoming reality. Our service organization provides everything you need to profitably run your Jenbacher power plant. You choose your tailored level of support, and we will deliver everything from the digital myPlant asset performance management solution for optimized uptime and reduced lifecycle costs, all the way to remote as well as fast on-site service support. We also run a remanufacturing program for efficient overhauls and provide you with comprehensive conversion, modification, and upgrade packages to help you make the most out of your Jenbacher gas engine. Let's look at a few of the most popular Jenbacher solutions for North America. Most Jenbacher power plants run in CHP mode and use up to 40% less primary energy compared to conventional generation of heat and power. We offer innovative microgrid solutions for a stable 24/7 power and heat supply, even if cities face a blackout. With our innovative greenhouse solutions, We power and heat the greenhouses and clean the exhaust gas for use as fertilizer promoting plant growth. Jenbacher-powered data center power plants deliver lower emissions along with fast start capability based on reliable pipeline fuel operation. Using the renewable wastewater gas in Jenbacher engines provides 100% of a sewage plant's energy needs and, in the long run, significant cost savings. With our hydrogen options, we are prepared for a CO2 neutral world, supporting you all the way through this time of transition. By choosing Jenbacher gas engines, you decide for a greener and more profitable future. INNIO, energy solutions, everywhere, every time. And now it's my pleasure to welcome you to this webinar titled Jenbacher North America Presents Generate Power from Sewage Gas Using Jenbacher Gas Engines. Today's presenters are Luis Ampudia and Christian Mueller. Today's webinar will run for approximately 1 hour, including about 15 minutes for question and answers. Please make sure to answer the survey questions found in the widget bar at the bottom of your screen and download our brochure. And also, don't forget to enter your questions. Now I'll hand over to Luis and Christian. Gentlemen?
Thank you, Mark. This is Luis Ampudia with INNIO Jenbacher. I'm a senior sales manager in the Houston office, and I'm going to start the presentation. As you may well know, INNIO Jenbacher is an expert on fuel gases and taking advantage of their caloric content. In this case, sewage gas is one of them, but we have many others that we can work with. As landfill gas from landfills, which is basically also biogas, and coal mine gas, which is methane that is produced in the coal mines, and it has a lot of hydrogen on it, but also methane. It's a high energetic gas, but it's at low concentrations. We also have associated petroleum gas, which is flare gas from the oil wells that has lots of heavy carbon molecules that we have to get rid of. And also we deal with syngas or wood gas, but also lately syngas is being produced with plastics. Also, we can have blast furnace gas with high concentrations of carbon monoxide, which is once oxidized produces energy and is converted into CO2. And we also work very well with propane gas, although the engines are derated a little bit because of the knocking factor that could be produced by propane. Last but not least is hydrogen, which we can work with from concentrations of 25% with no effect on the engines at all to 100%. That is the goal to reach for the new zero carbonization. We have over 600 megawatts of Jenbacher sewage gas engines worldwide, and the biogas is produced by the fermentation of the sludges produced by the first aerobic digestion on the wastewater treatment plants. More or less, a city of 500,000 can produce 1 megawatt of electricity with the sludges. That it could cover almost 100% of the energy needed, but it will depend on how the anaerobic digester is operated. It could be with mesophilic methods on the anaerobic digester or thermophilic. Thermophilic produces the most of biogas and highest concentrations of methane, but then again, it depends on the philosophy of operation of each wastewater treatment plant. The typical gas quality of wastewater treatment plant ranges between 50 and 70%, and that's because of the philosophy of operation, either mesophilic or thermophilic. Mesophilic is around 35 degrees Celsius, and thermophilic is about 38 to 41 degrees Celsius. The problem with the thermophilic, although it produces more methane, it is the bacteria, anaerobic bacteria, are more susceptible to temperature differences. So the temperature control that provides with our engine is very precise, and we can control exactly how the temperature could be. This gas tends to be high in sulfur and siloxanes. Siloxanes, once in the engine, can crystallize in a kind of ceramic that blocks the heads of the cylinders. So a gas training needs to be used in order to get rid of the siloxanes and sulfur that can oxidize the interior of the engine. Once the sulfur, in this case H2S, is in contact with water, it can transform into sulfuric acid, which is no good for the engine. A simple diagram of how this works is the sewage sludge gets into the digester. In the digestion, in the anaerobic digestion, the sewage gas or biogas is produced. Then it's sent to a gasometer with the gas compressor, which in turn is sent to the engine as a fuel, and it produces electricity. The jacket water is sent to a heat exchanger. Usually it's a plate heat exchanger that preheats the water that is going to be used in the digester with the purpose of heating the digester. Once it's preheated by the jacket water, is sent to the exhaust gas heat exchanger, which elevates even further the temperature. If they have too much heat, it could be sent to a buffer tank where it says heat consumer, and the buffer tank will retain the hot water for a period of time. In the case it's needed immediately, it's sent to the digester, basically around the digester and on the floor, and it heats it up. Once it heats up, it's returned to the again to the first heat exchanger, and electricity is produced. I remind you, please, if you could, make sure to download the brochure, ask questions in the questions widget, and fill out the survey, please. Thank you. As an example of how much energy we can produce, basically a plant of 190,000 million liters per day, that is more or less for 500,000 people, will produce 10,000 cubic meters of biogas. One note to say is that a cubic meter of methane has a power of 10 kilowatts, a little bit more, like 10.53 kilowatts, but for these purposes is 10. And the concentration of methane in the biogas is usually 60%. So 6 kilowatts per cubic meter in the biogas. as in Note 1. So with that, and it produces about 25, it has a caloric value of 25 kilowatt hour. And the efficiency of the engine is 40%, so it will produce 1,000 kilowatts electric of pure electricity, which is very good. So the trick here is to remember that every cubic meter of methane is 10 kilowatts. Our products. We not only configure our engines to produce electricity, but we need to evaluate the fuel as a methane number. Usually the biogas is at 60 methane number. Pure natural gas around 90 methane number. We also have methods for avoiding the emissions such as NOx, CO, and other emissions that could be harmful. We not only focus on electrical efficiency, but in thermal efficiency as overall efficiency. That could be up to 90%. The engines are not only rated for what they can produce at sea level, but there are many factors that contribute to the performance of the engines. One is altitude. Usually our engines are very good up to 2,000 meters. They almost do not derate. Also, the higher the temperature is, it starts to derate. So our engines can be very, very good up until 40 degrees Celsius or 104 Fahrenheit. And obviously also the humidity. The humidity is important. So every engine is specific for each location, and we custom design each engine in order to produce the best result. And finally, the application. If it is for CHP, combined heat and power, generation only, biogas, greenhouses, etc. We have engines from about 300 kilowatts, the Type 2. The Type 3 goes from about 600 kilowatts to 1,000 kilowatts in 3 different engines or versions, the J312, J316, J320. The Type 4, also another 3 engines, go from about 800 kilowatts to 1,500 kilowatts with the versions 412, 416, and 420. Another group is the Type 6 that goes from about 2,000 kilowatts to 4.4 megawatts. We do not have it here, but we have the 624, which is 4.4 megawatts, and the J620 is 3.3 megawatts. Our scope supply is wide. We provide silencers, we provide radiators, ventilation systems, cooling systems, and other kinds of systems that, like the exhaust gas heat exchanger and other heat exchangers, oil tanks, medium voltage panels, containers. So a wide range of balance of plant that we can provide. As an example, this is a biogas plant with containerized 420 engines, in this case, 6 420 engines, a large biogas plant in Europe. And we have a configuration that I already explained one. So the water is used In a decoupling heat exchanger is preheated and then is sent to the exhaust gas heat exchanger and produces water with a temperature of 190 degrees Fahrenheit. This is the inner system for cooling the engine. And here you can see the application for a sewage plant. This case is in Michigan. With this, I pass it over to Christian. Go ahead, Christian.
Yeah, good afternoon from myself, Christian Mueller. I'm a sales manager for Jenbacher, based out of Houston. And I'll go through the second part of the presentation to talk a little bit more about some of the important things to consider when installing engines on sewage treatment plants. And the first topic is really what Luis already alluded to, gas quality and gas treatment. So the first thing to consider is H2S or sulfur. So sewage gases, as well as other biological gases from digesters, they typically contain quite a bit of sulfur. And the issue becomes when you burn these gases in an engine, the lubricating oil becomes acidic, and that loses its lubrication capability, which means that now you have to change your engine oil more frequently, and also the moving parts of the engine become more worn or quicker worn, because obviously you have a lesser lubrication capability. So you can obviously measure the acidity of oil by regular lube oil analyses, and that's the best way to determine if you have a sulfur problem on the engine. And if your H2S is very high, like in the 2,000 to 4,000 ppm range, then also some engine components can suffer direct damage from that. And there can be corrosion on metal parts in conjunction with the condensate, as H2S combined with water forms sulfuric acid, and that will wear directly your components. So not only the lube oil will be less lubricating, but also you have that direct corrosion on the components. And this is especially visible in the exhaust, where you will have deposits on the exhaust gas heat exchanger if you have condensate there, which is the case if you drop the temperature too low in the exhaust heat exchanger. So sulfur has a variety of different ways it impacts the engine. And the first thing when we look at sewage treatment applications is always to get a baseline of how much sulfur is in there, and then we see how that might affect the maintenance of the engine. If we look at the exhaust heat exchanger, which I just said, this is a picture which really shows what sulfur can do. It forms all these deposits there, corrodes the material. And one way to partially avoid the problem is to keep the exhaust temperatures higher, so be above 356 degrees Fahrenheit at the exit of the exhaust heat exchanger, so you don't extract that much heat out of it, and that prevents condensate, which is one of the main issues, as that forms sulfuric acid with H2S. So these exhaust heat exchangers, if they do experience condensate or high sulfur, they will extremely quickly wear and then need to be replaced, which can be a considerable maintenance cost. So that's one thing to consider. One option also would be obviously to not have an exhaust heat exchanger in the first place, but obviously then you reduce your total recoverable heat from the engine. So exhaust heat exchangers are quite common for these type of applications, and you just have to make sure your gas is clean and doesn't have much H2S in it. The next concern are siloxanes, and on the right you show we have some pictures of components of the engine, the valves and the cylinder heads, pistons, which show this white powdery substance on it. So siloxanes are very common in sewage gases. They come from cosmetics and other things which people use and obviously end up in the wastewater. And silica and any number of silica components, they, during the combustion process in the engine, where obviously you have very high temperatures, become silicate. which is in essence a fine form of quartz or sand. So in essence, you have this sand-like substance in there, which is obviously the last thing you would like to have in an engine, as it will start pitting the valves. It will form these crusts on the pistons. It will coat pretty much every part of the combustion chamber, and will obviously affect the combustion. It will lead to knocking combustion, as the gas does not burn even anymore. It will lead to abrasion and ultimately failure of that cylinder, or potentially the whole engine if you have that issue on all the engines. And then you'll have to replace the cylinder heads, the pistons, valves. So rather costly. Let's say some operators used to just prefer to do more often maintenance on these parts and just replace them rather than treating the gas. But with components in modern gas engines like Jenbacher's, they're really designed to last a long time. So if you're replacing these, rather expensive pieces of equipment more frequently, then overall you're going to have a higher cost of operation rather than cleaning the gas. So definitely you'll want to clean the gas to avoid these issues, which are not only costly but also a reliability concern, as obviously the engine will go down once you have a situation like is shown there on those pictures. So there are different ways to remove siloxanes as well as sulfur. A common technology is an activated carbon absorber, which is really very efficient to remove siloxanes from sewage gas and biogases. It basically absorbs that. Let's see, the issue with the activated carbon absorber obviously is that once the media, the carbon, is saturated, then you have to replace it. So there's a higher cost of operation in a sense, especially if you have very high quantities of siloxanes. But the cost of such an absorber is, let's say, relatively reasonable. If you do have very high concentrations of siloxanes or sulfur, then you might want to go with a regenerating filter where the absorbing characteristics are also very good, but the main advantage is that you have low ongoing operating cost. In this case, it says you're approximately 15% of the activated carbon filter, since once the media is saturated, you can regenerate it, and then you can reuse it, and you don't have to have the replacement of the media, the absorbent. So these are obviously more expensive, higher investment cost, approximately 5-6 times more than an activated carbon absorber, but you have lower operating costs. So typically what one does is one looks at the gas quality and then sees what's the amount of H2S or siloxanes in there, and then one decides which is the best technology to remove those contaminants. And Jenbacher can certainly assist with that selection process. The next feature, which is very common on wastewater treatment plants, is, or we see it more and more common, is gas blending or dual fuel. So what is dual fuel? Basically, that means that you have two fuel trains coming into the engine, which are different gases. So in this case, it would be typically natural gas and the sewage gas. And the Jenbacher engines, basically our Type 3, Type 4, Type 6, which are the primary engines we use for the sewage gas applications, they have the ability to use this dual fuel capability. So why would you want to do that? Well, for example, if you're running normally on sewage gas, but during a resiliency event, which might mean that the sewage gas is no longer available, or maybe there is any other plant outage which leads to an issue on the biogas supply or maintenance of the equipment, then you can switch to natural gas and then run the plant on natural gas to continue producing power. And that's potentially especially important if you have an outage of the electric grid at the same time, so you can island your sewage treatment plant and continue operating all the pumps and keep the sewage and the water moving. So that's one important aspect. The other aspect is that you might want to blend actually the gases. So the sewage gas production may vary over the course of the year. And during times when there are lower production volumes of sewage gas, you can actually add natural gas and keep the output of the engine steady, so you always have the same production of electricity there. And that would be a blended gas operation. So basically, we have those different options available. One would be simply just switching gases when the engine is shut down, which obviously is the easiest. You just switch from one fuel supply to the other, and the engine changes the set points of combustion, as natural gas and biogas do have different combustion properties. The second would be a switching when running, where essentially you would gradually reduce the supply of one gas and then up the supply of the other, which in essence would be a blend during that switchover process until you're running on 100% gas of the second gas after the switch. Or you could do the dynamic blending while running, that you're continuously blending the fuels to basically maintain output. So we offer all those three options on our engines, and the blending can be done directly on the engine. So it doesn't have to be off-skid. We basically have, as I mentioned, the two fuel supply trains coming in, and then we handle the mixing and the blending and obviously the controls of doing that. And you can have any number of different set points which determine when and how you switch or blend these gases. The neat thing is that due to our long experience we have in these type of applications, we have been able to basically achieve very good outputs on both fuels. So typically an engine is optimized to one fuel, so you get a better output, better efficiency on one fuel, and the secondary fuel always has a little bit of a disadvantage, but we're very close in terms of output and efficiencies now also on the secondary gas, just through optimizing the engine. So really you have often a very similar output on both gases, which obviously is what you would desire to have. So if we now look at the two gas supply trains, this is just a schematic how it looks. So basically, obviously you had to have your biogas supply train and your natural gas supply train, and both would come together at the air mixture, gas air mixture valve there, where you add the air to it for the combustion process. And our controller, the Diane, would then handle the blending and the dosing of those two gases. And basically you could set any variable blend of the two or do a switch between one and the other. That leads me a little bit into the next section, controls, which are also very important. And just again, a reminder, if you have any questions, please do put them in the chat box here. So we'll talk about that when we're done here. As far as controls goes, the basic scope is the module control panel, the Diane, which you see here on the bottom. It interfaces to all the systems on the engine, obviously, as well as the gas train, which is doing the gas blending if needed. Then on the top, it shows you some of the balance of plant, the key items, the cooling systems, exhaust gas after treatment, any auxiliary systems. So we also interface with those, either be it in our supply those systems or third-party supplied. We create a customized plant control scheme on the display, so you have an overview of all the components. We also offer different bus systems, interfaces, remote systems, so you can connect in any number of ways to the system depending on what you want. And then lastly, on the bottom left, it shows the mains connection. So you'd connect the generator obviously to switchgear, which can be controlled by our controller to parallel the unit with, for example, the mains if you're running in parallel with mains utility power. If we have multiple engines, then we also offer a master control panel, which basically can parallel multiple generators. It can also do the synchronization of tie breakers, main breakers. You might have different configurations there of those systems of the switchgear. So you can parallel multiple generators and run them either in disconnected island mode or in parallel with the utility. And there might also be auxiliary balance of plant controls, ventilation systems, things like that in the building, which can be controlled. And lastly, like the Diane genset controller, you'll also have all the different remote options there. So really, it's quite a complete controls package there, depending on what is desired for the installation. Next, a little bit about service. So obviously, for a sewage treatment plant, uptime and reliability are very important. Most of these engines run continuously 24/7, as the biogas is produced 24/7. So one of the best ways to maintain uptime is basically having those units hooked up through a remote service. We call that our myPlant, so that we can assess literally thousands of data points on the engine. They automatically get logged. And when there is an issue which arises, basically remotely we can check into the engine and see what's wrong. So that in most cases allows for a fix with a skilled operator at site, a tech on the phone who's logged into the system could diagnose the issue and assist the local technician in fixing it. And we've seen an over 65% remote fix rate of problems which previously had required somebody to go out to site. So not only is it quicker, but it's also less expensive, obviously. So two benefits in one. And it really gives you this 24/7 remote monitoring feature, so you can also get the data on your phone and get alerts there. So it really makes you have control of your plant at any time without even physically being there. A part of that feature set is really the advanced monitoring, which has an early detection of maintenance events. So the goal, especially with applications like this for continuous duty, are that you want to do, in a way, an early detection of faults. So not only for corrective, but also preventative maintenance issues, you can basically, through having all these data set points, monitor the health of the engine, and you can see through pressure sensors, temperature sensors, it gives you a good indication of how well the engine is doing, and it gives you an early indication of when parts might need to be replaced. For example, spark plugs. They're quite, through monitoring the ignition voltage, you can basically predict pretty much exactly when that spark plug is going to need to be replaced. So we're doing a lot of that now, getting more into a predictive maintenance where really components are replaced before they fail. And in some instances, they might even last longer than the standard maintenance interval. If, for example, your gas is very clean, you might be able to extend certain things and save costs by that. The second aspect, as it relates to biogas applications, is that if your biogas is clean, our spark plugs are exceptionally long life. You could get 8,000 to 9,000 hours of life out of a spark plug, which in many cases typically would only last 2,000 to 3,000 hours. That's a very common number, but through these optimized spark plugs for biogas operation, we've gotten very long intervals on spark plugs on the Type 3 and Type 4 engines. So also there, we're continuously trying to improve the longevity of these components optimized for biogas operations. But one of the key things always is to achieve low cost of maintenance and low cost of operation is really to have your gas clean. That is the one biggest thing which affects maintenance cost on a sewage plant if you're running biogas. Now I want to talk a little bit here about some of the references in North America. And as Luis initially mentioned, we have, Jenbacher has a tremendous number of generators installed on wastewater plants all over the world and also in the US. But I tried to just pick a couple here, which are interesting. As an intro, we have about 1,000 Jenbacher gas engines installed in North America, which would be the US and Canada. That's this definition. In Mexico, we have even plenty more. And interestingly enough, of those 1,000 plus generators, approximately 50 are installed in biogas applications, including sewage and landfill gas. So Jenbacher has a very strong background in that. I would say, especially on the non-natural gas side, we have an excellent reputation, and landfill gas and sewage gas customers have often looked at Jenbacher as the first choice because of that experience in those biogas applications. So here's the first site I wanted to talk about. This is in the city of Austin, the Hornsberry Bend Biosolids Management Facility. They have a J316 installed there. That's an 876 kW biogas genset. It's installed in this custom-built enclosure here, which includes full heat recovery. So you see that kind of on the top, that's your exhaust heat recovery. So it's a full CHP. This unit was installed in 2012 and has been running continuously since, providing electricity for use at the plant. So initially, they actually were almost self-sufficient with this generator, but obviously as the plant expanded, they are now importing some of the power. But it definitely contributes to a substantial reduction of their utility bills by producing their own power using the sewage gas they produce. Just recently, this engine was overhauled at 60,000 hours, the major overhaul. So basically a new engine came in and it continues running and will be good for another 60,000 hours. So again, very proven, very reliable system here, which has been in baseload operation for now about 10 years. One other interesting aspect, a little bit, obviously we all know there was the freeze here in Texas in February, and these systems did operate, but in general, I think there were quite some interesting things learned about how a freeze affects probably lesser the engine. These engines are designed to run at pretty much any temperature, so they don't mind the cold weather, but there's plenty of support systems bringing the gas to the engine and other systems which are affected by adverse weather. So it's really not only the engine which has to be looked at for resiliency, it's the whole system. And any part of it which might be impacted by let's say, adverse weather conditions. So I'd say that's generally a thing we have noticed here for the Jenbacher gensets we had running here. A lot really depended on how the support infrastructure handled that cold weather, and if, for example, a certain valve froze and then maybe disrupted the gas supply. But definitely these gensets did support the grid and were a part of the puzzle of trying to at least keep the lights on for as long as possible. The next one is a wastewater site in Michigan, St. Cloud, Michigan. So this is a 312, so it's the same engine category as the 316 in Texas. And the interesting thing on this one, it's a 633 kW unit, which has a dual fuel capability. So it can run on sewage gas and natural gas. So this wastewater site there in Minnesota, they launched an innovative project to use renewable energy to power the plant. And not only did they decide to install a sewage gas generator here, but they also installed solar PV. So they had enough space there, and they really now have a combination of a generator and solar PV. So you could almost call that a microgrid with pure renewable energy. So this unit runs primarily on sewage gas, but there are cases when the biogas production fluctuates, and then automatically you add natural gas to it and blend it. And this unit can also run purely on natural gas in an isolated condition if required. For example, if there would be a disruption of the sewage gas supply. So it has that as a resiliency feature to basically operate on both gases or blend of one or the other. The container you see there, that's the Jenbacher factory container. So that's in a way our standard container product, which we supply turnkey. This site was engineered, installed, and is maintained by one of our channel partners, Clark Energy, there in that region. And then lastly, this is also an interesting project. This is one in Michigan, Grand Rapids Water Resource Recovery Facility. It has 2 of our J420 natural gas units. So those are rated at 1.4 megawatts each. So this is 2.8. But the interesting thing is, this is at a sewage plant, but the primary fuel is natural gas. So what are they doing? The wastewater treatment site decided to go the RNG route, meaning they're upgrading their biogas to natural gas, basically removing the CO2 and having pure methane, also removing the contaminants, obviously. And they export that renewable natural gas to the pipeline, but they have a lot of need for electricity and thermal energy at the site. So it was worthwhile for them to install these two natural gas CHP systems to provide the heat to the digesters, especially during winter, and also support the plant with 2.8 megawatts of electric output. In addition, it also improves the resiliency of the plant, as obviously if the grid were to go down, then you'll still have this 2.8 megawatts of generation there to support the plant in island mode, so they can disconnect the plant from the grid and then continue to running these generators. Again, these are the Jenbacher factory containers you see there. These are the 40-foot containers housing the J420s with the full exhaust heat recovery. On the bottom, you see that silver exhaust heat recovery unit. So basically the exhaust goes out of the top of the container from the engine. It goes down to that exhaust heat recovery unit, which in this case produces hot water, but it would also be possible to produce steam there, and then it goes up again onto the container where you have your silencer and stack. This installation was also done by our partner Clark Energy there. So again, from my first application there, which is just running on sewage gas, to this one, which is just running on natural gas, we really have any number of different types of applications possible for sewage treatment plants. And also, if they decide to go RNG, then adding a natural gas CHP is very worthwhile, and does improve not only the resiliency but also the operating cost. It might even make your RNG more valuable, as you do get credits for this energy efficient system here, which supports the RNG process. So with that, I would say we have some time for Q&A. Mark?
Thank you, Christian and Louis, for your presentation. Thanks to all of the attendees for your attention. We will now move into the question and answer session. So if you have questions, there's still plenty of time to enter them into the widget. Before we begin, I would like to once again ask you to complete our survey, which is also found in the widget bar at the bottom of your screen. This just lets us know how you're finding our webinar so far. Also, I want to remind you that you can download our brochure, which will give you more information on our solutions for wastewater and sewage gas. If you'd like to get in touch with us right away, there are a number of ways to do so. You can either let us know via the chat or via the Contact Us widget on your screen right now. Of course, you can always fill a form at www.jenbacher.com/America or www.INNIO.com. And as a reminder, today's presentation will be available on demand in just a few hours, so please follow the link you received earlier if you would like to see and or hear the presentation again. And with that, let's get into some question and answers. We've got quite a few. Let's begin with this one. I will paraphrase a little bit. How can you economically extract or manufacture biogas from existing wastewater treatment plants that currently have no biogas digesters? The solids are dried and hauled away via trucks. Gentlemen?
Luis, do you want to take that?
Yes, go ahead. You can, instead of drying them out, you can basically dewater them and put them in a digester. That way you can take care of them with anaerobic digestion. But that needs to be a purpose specific anaerobic digester. Those sludges have a value as fertilizer or soil enhancer, but the only thing that you need to do is just to direct those sludges to an anaerobic digester, and that way you can have your biogas. Do you want to, Christian, to extend a little more?
Yeah, I guess as a general comment, so every waste stream is different. And I mean, the one site there in Austin was also a biosolids waste processing site. So they also have solids there as part of the process. So it really needs to be looked at on a case by case, and there are certainly the experts out there who build the digesters who can evaluate if it's worthwhile to do it. I mean, the cost of a digester is potentially significant. So one has to really look at the waste and the amount of waste, and then the feasibility of putting in a digester. But yeah, that's basically how you would get biogas.
Yeah, but as a rule of thumb, a 500,000 inhabitants wastewater is about 500 liters per second. So you need at least to have half of it in order to be profitable. So you need at least 250 liters per second of wastewater in order to have profitable or feasible digester. Go ahead, Mark.
Okay. Yeah, so I hope that helped. Moving forward, the question is, does it help to run the engine at a higher temperature due to gas quality?
The higher temperature, no, I mean, not really. It benefits to run the exhaust at a higher temperature, meaning the exhaust of the engine, you know, it's, let's say 700-800 degrees as it comes out of the engine, and then you just don't cool that exhaust down so much. The recommendation would be to keep it above 350 degrees approximately. So obviously you're going to cool the exhaust a little less and extract a little less heat. So that's the main thing you can do to prevent corrosion, is to keep the exhaust temperatures higher. The engine itself, I mean, it runs at whatever's the ambient temperature. That does not really, you don't want to artificially increase the temperature of the engine by, let's say, reducing the ventilation. The engine does prefer cooler temperatures, obviously, for combustion. So it's mainly the exhaust you want to modulate on the temperature side.
Great, thank you, Christian. Here's another sort of hardware-oriented question. Where is the large carbon filter shown early on located? In the exhaust or in the fuel?
It's in the fuel. So there's a fuel treatment skid. So basically the biogas coming out of a digester is very low pressure. So it goes through different stages of compressing the gas, of chilling the gas, removing moisture, having it run through an absorber. So there's different steps involved with making the gas basically dry, removing the contaminants, as well as having at the right pressure. So these engines I just showed you, the Type 3 and Type 4, they need about 2 to 4 psi. So low pressure, but still the pressure out of the digester is much less than that. That's in the fuel inlet. You don't really see that necessarily right next to the engines. The skid can be there, but sometimes it's also in a centralized location. But yeah, it's on the fuel inlet side.
Okay, keeping it in a sort of a hardware direction is a question about, does INNIO supply gas cleaning systems?
No, we don't supply gas cleaning systems, but we can suggest several manufacturers, and we can guide our customers through them. The ones that I personally prefer are the biological type of for hydrogen sulfide, and because they are quotation marks renewable,
regenerative.
It depends on, but yeah, and the siloxanes is another. That's a chemical. It's carbon that needs to be active carbon that needs to be replaced constantly. Go ahead, Christian.
Yeah, okay, we'll be happy to recommend, depending on your gas quality, the appropriate H2S and siloxane removal techniques, and we know some companies who do that for you.
Okay, excellent. Thank you. Guys, let's see. Here we go. Some wastewater treatment plants are upgrading their sewage gas to RNG. What happens with the generators in that case? I think, Christian, you were talking in this direction already.
Yes. So there's really two cases. One is an existing plant which might have biogas generators there, and they're deciding to go RNG because it might be more profitable based on the circumstances they have there at the site to do that. Then what you can do is you can basically convert the sewage gas generators to natural gas. I mean, you already have the generator there. The engine itself can run on either gas, and you might want to just change some parts to optimize it. But yeah, you can basically convert that unit to a natural gas generator and then keep running it as a CHP. So the generator can continue to operate there. Or obviously, if it's a new plant, like that one I showed you, then you can design it from the get-go around a natural gas CHP system to support the RNG process.
Great, thank you. Continuing on, do larger wastewater treatment plant facilities have added complexities compared to smaller facilities, or is CHP scalable?
It is scalable. I believe our largest CHP plant is with 10 J620s, each one rated with biogas about 2,500 kilowatts. And that is located in Mexico for the wastewater treatment plant for the whole city. So it's a large operation, and it was scalable. They operate 24/7, and it does not require on the engineering side more than a basic one with only one engine. It has complexities, of course. The cleaning system has to be bigger and other things, but they are scalable.
Yeah, we have sites which first might have one or two generators. We have another one in Utah. We started off with 2 engines, and then they've now added step by step another 2. So as wastewater treatment plants grow, as cities grow, the installations can be expanded to include further generators.
Okay, thanks, gentlemen. We do have a couple minutes left, so if you have a question, please don't hesitate to type it in. If we don't get to your question live, we'll do our best to get back to you via email as soon as possible. Moving forward, is there a common voltage produced, or are there multiple voltages available? I assume this is across the various engine types.
Yeah, it's dependent obviously on what the customer needs. On the low voltage side, it's typically 480 or 600 volt. And then medium voltage is 4160, 1247, 138. So the highest voltage one typically sees on these generators is 138, and that's more common on the very large engines. The smaller engines, meaning less than 1 megawatt, typically operate on low voltage, 480 volt being common, but the generator can be selected based on the project and the customer's preference.
Super. Okay. Christian Lewis, let me see if I can make this into a question. I think this gentleman is asking about fuel consumption. If there's a calculation or maybe any thumb lines or rough guidelines you'd like to comment about fuel consumption in wastewater treatment.
I don't have it on the top of my head, but you can go back retracing your steps. There was a slide with cubic meters needed to produce 1 megawatt at the beginning. So
let's see.
So yeah, basically the typical efficiency of an engine is somewhere around 40%.
It's 10,000 cubic meters of biogas per day to produce 1 megawatt. So that's more or less what you need.
Let's just say if you can send us the quantity of gas you have, then we will calculate it for you. Let's just say it in that way.
Perfect. So for the person who asked that question, we'll try to get back to you. And if we understand your question, we'll try to answer it. If we don't understand it, we'd be happy to talk to you further about it. We've now reached the end of today's webinar. As I mentioned, if we didn't get to your question, we'll do so via email. Please be reminded that today's presentation is available on demand, so you can visit the platform and listen and watch again if you'd like. And you can also share the presentation with others within your organization who may be interested. On behalf of Christian, Lewis, and Jenbacher North America, thank you for joining today's webinar on solutions for sewage gas. We hope you found it interesting, and we're looking forward to speaking to you soon about how Jenbacher gas engines can support your projects. Thank you very much, and have a nice day.